Okay, here we go. We got, let's see, I'm going to do three sort of smaller lessons on means. I think this is what you guys will need the best or the most. So here's the problem. We got the lifespan of a fully charged cell battery, and it's normally distributed with a mean of 14 hours and a standard deviation of 1 hour. So sometimes we'll write this normal with the mean of 14 and the standard deviation of 1. So that's what we call mu is the mean, and that's the standard deviation sigma. Okay, so take a look at question 1. It says if you randomly select one cell phone, what's the probability the battery will last less than 13 hours? Well, I'm selecting one cell phone. Well, I know the distribution of all cell phones is normal because it tells me that. And I know the mean is 14 and the standard deviation is 1. So what's the probability the battery will last less than 13 hours? So 13 hours is about right there. And the probability that it's less than 13 is that area. So the question is, how do I find the area? It's the probability that x is less than or equal to 13. Well, I could find the z-score, which is 13 minus 14 divided by 1, which is negative 1. And I can look that up on the table, and the table will give me that area. Or, so I can do that and then use table. Or I can just do normal CDF, and it's going to be the lower, the upper, the mean, and the standard deviation. So that's going to be, the lower will be a number way down here, like negative 9999. The upper is 13, right? That's the upper region of my shade. The mean is 14, standard deviation is 1. Okay. And if you do that, 0.159 or 15.9%. Okay, so what is that telling us? That's telling us if the battery lifespan is normal, meaning, and the average is 14, so average of lifespan is 14 hours. Some are going to be above. Yep. Some are going to be below. And to be 13 or less is going to be about 16%, 15.9. Okay, so now let's take a look at number 2. Number 2 says if you randomly select 10 cell phones, what's probably at the average of those 10? So now I'm talking about average of 10, not just one phone. Well, we need to know what is the distribution of the average of 10 phones look like. In other words, if I take 10 phones and I find the average lifespan, what's the average going to be? And the center is going to be 14. And we're going to talk about why it's normal here in a sec. But this is the distribution of x bar, or the distribution of all averages of, of the average, let me write it like this, of the average of all possible samples of size n. And we know that's normal if 3 conditions happen. 1, they're random samples. 2, n, which is 10, is less than 10% of the population, which is true. And 3, if n is bigger than or equal to 30. Uh-oh, it's not. So this fails. But, and I don't know if we mentioned this in class very much, if the population is normal, and so is this. Any, for any n. Okay, if this population up here is normal, then that's going to be normal, no matter what n is. So the mean, we call it mu x bar is 14, and the standard deviation, remember what that is? Think about it. It's sigma over the square root of n, which is 1 over the square root of 10, which is 1 divided by second square root of 10. I got my calculator over here, 0.3162. And so now what is this question asking? If I select 10 phones, what's probably the average is less than 13. So now I've got this. Notice the standard deviation is smaller, so my data is squished in tighter around it. So now I'm finding that area. So I could find the z-score and say, oh, 13 minus 14 divided by 0.3162, and then use a table. Or I'm going to go normal, CDF, the minimum, the maximum, the mean, and the standard deviation. I'm going to go ahead and put 1 over square root of 10, because that's what I'm going to put in my calculator, because then I don't have to round numbers off. So if I put that in my calculator, let's see, lower upper mean standard deviation, 1 divided by square root of 10. Are you doing that on your calculator too? Pause it and do it, then turn it back on. See, I don't have to pause, but because you can pause. Oh my goodness, so this is going to be 7.83 times 10 to the negative 4, which means move the decimal over 4 places to the left, which is 0.000783, which is 0.0783%. Okay, so look at what we're talking about here. Why is that number so different from that number? Well, this is the probability of one phone less than or equal to 13 hours. This is a probability of the average of 10 less than or equal to 13. Okay, and what's going to happen if I do 50? What changes? This number right here, because my sample size is 50, so that's going to make my standard deviation smaller. Okay, and so what's my graph going to look like if it's smaller? Looks even more squished in, and this area is going to be tiny, isn't it? Okay, so I'm not going to calculate that. I'm going to leave it at that, and hopefully that makes sense. And then I'll start with a different video for the confidence intervals. All right.